All right. Hey, everybody. Welcome to Earth Science, part 4 of the weathering lab. Finally, after this, you made it. This one works reasonably well. This one's not perfect, but it does achieve something that I want us to check out, which is what happens to soluble substances with water. And again, you should have seen this in the notes. You should have put it in the notes. And if you haven't, go back, go in order. It will save you work in the long run. To remind us of the work we did, salt is soluble, which means it can dissolve in water chemically. Now, you'll learn more about this when you get to chemistry and the different, it gets a little bit more complicated than we've got to face. We keep it simple, and it's stuff you already know. If you've ever made Kool-Aid, you've got the basics of how this all works, right? I'm going to take some road salt. This is the fancy stuff. It's not just sodium chloride. It's got some other things in there. Some magnesium chloride. We're going to put it in water. We're going to do the whole shaking thing. It's very similar to the lab in part 3, with the tweak being that there's water in there, and we got to deal with getting it in and out of there. It gets to be a little bit more tedious. However, we're also only going to do 5 minutes worth of data. So it's going to look and feel pretty similar, but we'll bang right through it. You guys are going to do great. So the premise is that I'm going to take this jar, dump some salt in. I want to get up in the high 200s. If you notice your graph here, it goes to 300. I don't want to go above that. And then we'll put it on the, I got a triple beam balance here. We'll get the mass, and then we're going to put in some water, shake it. But then we got to get rid of the water, and I can't just go dumping wet salt on this thing. So it'll have salt, water, we'll shake it. Then I'm going to dump the water out through the screen. And then I got to put the whole thing back on there. We don't really care about the mass of the glass. We need the mass of the salt. But it's going to be in that glass every single time. So we've got to be careful to make sure to subtract that out. So what I did is, if it's still right, is get the mass of the glass and lid at 299.2. All right. That's going to be really important because really every time you get a number in this column, you're going to have to subtract that out. Because all we want to think about is the mass of the salt. That changes, that goes down as the salt dissolves. This isn't going to change, but we need to get rid of it in order to get to the results of just the salt. So remember, subtract the 299.2 off of every single number. Okay. I took the same class as average data. I've got that right here. We'll fill that in as we go. You will have to listen to the YouTube video here. And again, I know this isn't as fun as these labs usually are. These labs are usually decent. So thanks for sticking through it on all this YouTube stuff. I know it's a drag, but you're doing great. Keep it up. What you'll have to do is listen for the number. I'll say at X number of minutes, the mass is this much. You got to be clever enough, A, to listen and note that, B, to subtract that 299.2 grams that the jar and lid are contributing to that mass so that you just have the salt. Okay, we'll do it 5 times and wrap it up. There's one important thing I'm going to do after the first couple. I'll show you that when we get there. But yeah, so let's get it going. I'll pause for a minute and take care of some of the logistics here so you don't have to watch that. Be right back. Okay, so I got the salt into the jar, got it massed out, and I'm going to tell you what it is. And again, to reinforce this, I know I just said it, but at 0 minutes, we right now are reading, just make sure that's in the slot there. Yep. 573.7. 573.7 grams. That's what goes here. Yeah, but not all of it because that much less has to be in there. Okay, I'm going to write that down here. 573.7. Okay. If you actually wrote 573.7 here, you're not doing it right. So you got to subtract out that 299.2. If you're sick of hearing me say that, I apologize. On average, with the group that we had in here this 1 year, the Wanda Fuca group from 2019, the class average was exactly 274 at the beginning. Okay. So here's the process. I'm going to grab some water. Should have done that. We'll put it in the jar. We'll get this thing going. Okay, there's our salt. We're going to dump in some water. I know how much water I'm putting in. It's just not important for the lab. I'm going to put this on. We're going to shake it for a minute. We're going to hopefully not make a mess. And then dump it. I'll do the same thing. You guys know how it goes. So I'll pause it as I start shaking. I won't make you watch the whole first minute again. All right, so same as last time. If you didn't do experiment 3, obviously you shouldn't be here. Go back and do experiment 3 first. It'll help this one make sense. All right, here we go. All right, it's done shaking. Now, kind of a mess in there. That's what it looks like. Now, all I want is the mass of the salt that's left. Some of the salt will have dissolved into this water, right? So I got to get rid of the water and leave the salt behind. Which brings me to a point that I want to bring up that's going to be helpful when we get to our rocks unit. This is the beginning of an experiment that we're going to do, that we're going to observe over the next, couple of months. When we get to rocks, we're going to need to use this. So you see it now here on YouTube. All I'm going to do is take this water that's just a product of shaking that salt in there. I'm going to dump it in there. Empty it out. Nice. There we go. So you saw me make this water. Nothing too tricky about it. I put some salt into water. I shook it. Dissolve some salt. It's basically salt water, right? So we're going to observe this. I'm going to put it in the front of the class. I'm going to do it 2 or 3 more times. We'll get a little more water in there. I'm going to put it in the front of the class, and we're just going to watch it over the course of weeks. All right. I'm going to put this back on the balance. We're going to get the mass of it. I think I'll pause while I fiddle around with the balance so you guys don't have to sit here and watch that. Be right back. Okay. On the balance, we have 507.6 grams. 507.6 grams for our 1 minute data. Remembering that don't put 507.6 because I've got salt and glass. We got to subtract the glass. Oh, I didn't put the lid on there. Rookie mistake. Be right back. All right, we're back. That's one of the things I usually yell at everybody at the beginning, saying, hey, you want to do it with the lid on? You want to do it with the lid off? Cool. Make up your own mind. Do it either way. But don't switch halfway through because that will screw it all up. And I almost screwed it all up. But we caught it in time. So if you got a number in there, get rid of it because what it should be is 525.0. 525.0. Once you subtract the 299.2. Do it right. Last year's group, or this is 2 years ago, actually. 254.5. Excellent. So, I'm going to get some more water. And again, I'm measuring this amount based on the mass. It's not really important for the lab, though, so I'm just skipping that for brevity's sake. Same old salt. Chuck in my pre-measured water. Lid on. Paper towel so I don't make a mess. And I'll pause and shake. Excellent. All right, here we go. Start, shake. Okay, there was a minute. Good thing I had the paper towels. It was leaking like crazy. I'm going to grab the salt water we did last time, just add more salt water to it. Again, this is for our rocks and... Whew, this stinks. This is for our rocks and minerals experiments. Trying not to spill so they can start all over. There we go. Getting low. It's going fast. There's my salt water. I think I'll save one more of those, and we'll call that good. I'll get the mess here and pause while I fiddle. All right. Oh my God, I did it again. As I'm recording myself. I said to myself, you should just do lid off at the beginning as well. All right, we are at 400. $446.8. 446.8 minus 299.2. Oh, calculators. 446.8 minus 299.2. All right, so I'm going to give you one just to make sure we're on the right track. I was at 446.8. I got rid of the 299.2, and that means I'm at 147.6. That'll be the only one of our data I do. I just want to make sure you're not putting those high numbers in there without the 299 grams of glass and plastic lid. Past groups, we're at 206.3. All right, 3 to go. So, I'm going to write that down, 47.6. Take my measured water, dump it on in there. Here we go. All right. That's gone. And we'll do one more demo of this just so that we are all on the same page, that all I have in this big 2,000 ml beaker. 1,500 ml beaker. I thought that matters. But all I've got in there is salt water. Put that back on the balance. Remember the lid. And this is going to be it for setting up my rocks experiment. So in rocks and minerals, this will be important. I've got the exact amount, doesn't matter. These aren't great for reading exact amounts, but I'm going to call it about 700 milliliters of salt water. 700 milliliters of salt water. I'm going to go put it on the front desk. If you are one of the people that come to school on your day on Crimson or Blue, it'll be up there. Check it out for the next couple of weeks. We'll see how it goes. As for this, I'll pause to use the scale. Be right back. Okay, for trial 3, the glass and the plastic lid and the remaining salts have a mass of 388.4. 388.4. Subtract that 299.2, you got our number. In past years, these guys got it down to 150.5 on average. All right. Looking good. Hang in there. We're getting close. All right, I skipped starting this trial with you guys, but that's okay. Got it done off camera. And there we go. So this salt water is just going to get dumped down the drain. You know what? Actually, I take that back. I'm going to keep it. I'm going to keep all the salt water from this. Maybe we'll try. I don't know. Maybe we'll try some measurement things. That could be cool. Maybe not. Doesn't matter. But might as well keep it. No harm in it. Lid on. Back on the balance. Let's see where we're at. All right, cool. So I've got the mass of the jar, lid, and salt is 359.2 grams. That's 359.2 grams. Again, go ahead and subtract out that 292, and you will have our 4-minute data. Class average at this point, 88 on the dot, 88.0. All right, that leaves us with only one trial to go. Let's take this. Let's measure the amount of water I like, which is right there. Dump it in. Hopefully we're rolling here. Excellent. All right. Lid. Already sets. There we go. Last one. All right. That's it. My salt water. All right. So still, same idea. We're still going to watch this. Now I got about 850 milliliters of salt water. That's not going to be tremendously different than it would have been before. It's gone. Jar and lid. We'll get the mass. We'll get back and we'll wrap this thing up. Okay, final reading for minute 5 is 335.5. That's 335.5. Subtract out that and you're good. Our class average was 42.4. And yeah, there we go. So what else is going to happen on this thing? Over here, this should be no surprise. 2 line graphs just like you did above. I'll be watching as you do your lab, so if something doesn't look right, hopefully I've caught you by now. But like if your class average line, say you want that to be in green, make your pen a little thicker for dots. At 0 minutes, the class average, maybe put a green dot in here to say those will be green. Is going to be just above this line because these lines, it's the same graph as up above, really. The one up above went by 3s. This one's going by 30s. So 270s right there. 274 is just a touch above it. So at 0 minutes, 274. At 1 minute, 254. At 2 minutes, 206. And then play connected outs with a thinner line, and you'll be in good shape. We probably should label down on the bottom here. And then, again, if you want to do it with text boxes, those are neater. If you want to draw whatever floats your boat. This is time in minutes. 3, 4, 5. We want 5 minutes. Okay. Give me some observations. Whatever you can see on that thing. Really, it dissolves away. I don't know. No big deal. All right. As for usual, there is a section of questions that goes with experiment 4. So what do you predict is going to happen to this beaker? And again, I'll leave in the front for a while. What's going to happen to that? Salt water went in. What happens to water when it evaporates? What happens to water when you leave it sitting in a room for a while? You'll have to figure it out. All right. One thing I skipped in all these videos, because I think you should do it now after you've done all 4 sections. What are some things you did in all of these labs? 4 sections, right? Breaking Alka-Seltzer, doing Alka-Seltzer in hot water versus cold water. Shaking of the sugar cubes, dissolving of the salt. You could put multiple things in some of these. So fill out as much as you can throughout the 4 sections for things that represented those different kinds of weathering. The Regents questions down here didn't look too bad to me. I just took a quick peek. I think they're doable. This one requires a little bit of graph reading, but in which section are the conditions like this? Just take a minute, try to read this graph, and get at those 2 questions. Yeah, none of this. And this one's just taking a minute with a flowchart. I think you can do it. All right, good job. That finally wraps up the weathering lab. It was a big one. I appreciate your perseverance. And have a happy February break. We'll catch you guys.